All right, so we're gonna answer these questions about Dave's Donuts. And it's good for you to just figure things out. So I know a lot of times in Algebra 2, they told you they wanted you to do it a certain way because you had to learn all the certain ways. Well, you've learned the ways, so I personally don't care which way you do it. So if you just want to plug numbers in until you figure it out, that's fine. If you want to use algebra, you can, but we really didn't have to use algebra to figure out any of these unless you just wanted to. But you could use the table. So at what price will Dave make no revenue? What do you guys think? No revenue, 0. So what do y'all think? $1, $5. They'll actually lose money if they charge between $0 and $1 just because it costs more to run the business than they're making on donuts. And then what about if they charge more than $5, they'll lose money? Why is that? Nobody's gonna buy a $6 donut unless it's like super, super fancy and you're in a place where people have a whole lot of money. So that's why it's that. I did also graph it in that space. I just took the points from the table and put them on here, and you can see where the graph is equal to 0 and where the graph and when it's negative. All right, and then the second question is, how much should Dave charge to maximize his revenue? So we're looking for maximum revenue. We're looking for the maximum point on the graph, or the price of donuts that gives you that maximum. So what price does give you that maximum? $3. Good. What is the most money Dave can make? The 160, where that maximum revenue is. Okay, and then my last class, people just plugged in numbers to figure this out, and that's fine. But there's actually 2 amounts that you could charge to get $100. I think several people figured out that one. What is it? I think I saw somebody had it on their paper. Fletcher, did you figure it out?
Is it like 1.78?
Yeah, $1.78 is that one. Did anyone figure out the one that's between $4 and $5? Did you just plug in numbers? Is that what you did?
Yeah.
I figured that's what everybody seemed to be doing. The other one, they could also charge $4.22 and make $100 in revenue. All right. So again, it's good to just try and figure an equation out without necessarily having some formal way that you do it. Being able to figure out this is a really good life skill for you to have. And trying something when you don't really know what to do, it's okay. I mean, the whole idea of doing the front side of our notes is just for you to try something and see if it works. And then we'll get it all sorted. All right, so on the note side, we're going to talk about solving equations with multiple representations. And those multiple representations are going to be numerical, analytical, and graphical. So if you decided when you were doing this problem you were just going to look at the table, that is solving it numerically. So make a table of values. Also, if you decided you were just going to plug in numbers until you found out which one worked, that's also numerical. That's called plug and chug. Right? Analytical is using algebraic methods. And the algebraic methods could be like factoring, using the quadratic formula. And then graphical, obviously, is looking at the graph. If you are going to solve an equation graphically, I'm going to write down the steps. What you do is you find the intersection. All right, so we just let the calculator do all the work. You just put in each side of the equation into y equals. So typically what I do is for y1, I put in the left side. It doesn't matter if it's the right or left. And then y2, put in the other side. All right, and then you go to the calculate menu in the calculator, and that's second, and then trace. And then a lot of things will come up. I can't remember the first one. It must say value, and then a 0, and then a minimum, maximum, and then choice 5 is intersection. That's what we're looking for when we're solving equations. Actually, it just says intersect, my bad. So hopefully you remember all of these from your previous classes. Probably in Algebra 2 you focused on this right here, but in this class we're going to do all of them. Alright, so let's look at number 1. A penny is dropped from the Empire State Building. Its height above the ground in feet after t seconds is given by h equals 1457 minus 16t squared. Demonstrate how you can use the table below to approximate the time at which the penny landed on the ground. Alright, so I want everybody to do this. I want you to go to y equals on your calculator. Alright, clear out anything that's in there. And then type in this function. In the place of t, we do need to put x. So this is a super common height equation just because gravity is the same always. Does anyone know where the 16 comes from? It's half of gravity. So when we're talking about feet, gravity is negative 32 feet per second, so it's half of gravity there. Does anyone know about this 1457? That changes from problem to problem. Do you know what this is in relation to the Empire State Building? The height of the Empire State Building. So this is dropped. It's not launched. It's just dropped. The penny is dropped. It's very dangerous. Do not try this. The penny is dropped from 1,457 feet, and we want to find the height after 7, 8, 9, 10, 11 seconds. So I'm going to go to my table. You could do this many ways. The table is going to be the fastest. We just need 7 through 11. So fill those in on your table, please. So what is going on with these negative heights? What? Yeah, it's going to hit the ground, and then after that, this formula is not going to make sense anymore because it doesn't go under the ground in this case. So between what 2 seconds do you think, or between what 2 times do you think this hits the ground? Yeah, it's going to hit the ground somewhere here between 9 and 10 seconds. So the penny is going to be at 0 feet when it hits the ground. And that's going to happen between 9 and 10 seconds. So we, using a table, unless 0 was one of your values, we can't give the exact time. So this just tells us to find the approximate time. So the penny landed on the ground between 9 and 10 seconds. That's a long time to fall. All right, and then for B, we want to find the exact time the penny landed on the ground using algebra. And so we're just kind of saying that when the height is 0, it's on the ground. So what we would do is go back to this equation, and in the place of h, we want to make the height be 0. Now, some of you might love algebra, and this might be your favorite way to solve it. Like it's definitely the most straightforward. The other ways you just kind of have to interpret a little bit. All right, so what I want to do is solve this for t. What would you guys do first to get t by itself? Yeah, there's different things you could do. You could move the 1457 to the other side and make it negative. Could we move this to the other side and make it positive? Absolutely. That's what I want to do. They both are 100% correct. I just like working with positive numbers a little bit better than negative. All right, what would you guys do now? Divide by 16, perfect. So you would do 1457 divided by 16, and it does not go evenly. Well, actually, maybe. You get a decimal, though. 91.06525. All right, and then how do I get t? Square root. Good job. Now, the other day, I can't remember what day it was, I helped a lot of people with a particular question. I was like, take the positive and negative square root. I said that like 20 times that day. Do I need to take a negative square root if this is time? No, negative time makes absolutely no sense. It's like the height of the penny before it was dropped. Doesn't make sense. So we'll just do the positive square root. And we were right. It's between 9 and 10, almost exactly between 9 and 10 seconds. Okay, we're doing great on time. All right, and then the next question. This one is using all three representations. So we did numerical, we just did analytical. Now we're going to do graphical. So we're going to verify this graphically. Now I already have it in my calculator. If I go to look at the graph, and I'm on like the negative 10 to 10 window, that's not super helpful. I can see though that it looks like it's crossing at about 9.5. I want to see a good graph though, so I'm going to change my window. You can just watch me do this, just hang in there. I'm not going to do negative time. I'm just going to have like a little negative. I'll have a -1 right there just so I can see it. And then we said that the height of the Empire State Building was at 14 something. So let's just make this maximum be 1,500. There it is. So that pretty much represents the height of the penny. And here is when the height is 0, and that looks very much like 9.543. If we wanted to make 100% sure, I'm going to go to the calculate menu again. And which one of those things do you think we would want if we're looking for that point where it touches the x-axis? See, we want 0. Good job. All right, so I get this little flashing guy, and we'll practice this more later. And we're going to hit enter on the left side, and hopefully it'll let me hit enter on the right side, and then enter again. And there it is. So we verified it. To show that on our paper, we're just going to do a little graph. Oops. that what it looked like? And I want to say this point right here is 9.543, comma 0. Alright, and then on number 2, we have this super weird equation that has a square root on one side and it's squared on the other side. And we're going to solve it using a graphing calculator. Like, I don't think there's another way to do it. Like, I can start thinking of things to do, and it was just almost impossible to solve by hand unless you're Albert Einstein or something. So, we're going to use the calculator. And we're going to do this right here. We're going to go through all of these steps. So the first thing we're going to do is go to y equals. And it's a good idea to practice this with me. Clear out whatever is there. And type in the left side. Oh. Type it in correctly. Alright, so yours should look something like this, maybe not colored, but something like that. Alright, so we want to find the answer to this equation is where these two graphs intersect. And so we're going to go through those steps where you're going to do second, and then trace. So this menu comes up again. We want number 5. And so you'll get this little flashing cursor typically on the y-axis. So you want to move it close to one of the intersection points, which is already there. And then hit enter 3 times. When this says intersection, the x value is one of your solutions. Alright, but there's two. There's 2 places where they intersect, so this one has 2 solutions. So we're going to do that again. Second, trace number 5. Make sure we move close to the other intersection points, and then hit enter 3 times. And that's going to be the other answer. It's possible we could get there by hand, but you end up with like a quartic equation. This kind of has like 5 terms, and I don't want to try. I don't want to do it. Alright, so this last one, I really like this question. So an up-and-coming artist has 85 followers on Twitter, and this number doubles every week. I should change this. Twitter's not a thing anymore, though, is it? We'll say on X. Do you guys call it Twitter?
I think
It's both?
I still call it Twitter.
I still call it Twitter.
Okay. I thought I was the only person not with it. Just kidding. All right, so it doubles every week. In what week will the artist first reach 1,000 followers? We may or may not do this 2 methods. Let's just see what happens. All right, so I am going to start off numerically, where I'm going to do a table. And the left column is going to be what week it is, and the right column is going to be how many followers this artist has. So how many followers does this artist have at week 0? 85. What about week 1? 170. So you just double 85 or multiply it by 2. And then we're just going to keep on multiplying by 2 until we get to 1,000. Okay, so we got over 1,000. So during this week right here, between the 3rd and 4th week, he gets 1,000 followers. All right, so let's see how much you guys can remember about exponential growth. I don't know. So 85 is the initial amount, so we would put that in the first, or in the front. And then we're going to multiply this by some number raised to the x. So this is doubling. What do you think that number is? 2. Okay. And what do we want that to equal to answer this question? 1,000. Nice. All right. There is a way to solve this by hand using logarithms. You guys remember logarithms? You remember the word? Logarithms are my favorite. But we'll wait. We're not ready. We're not ready for logarithms yet. So we'll just do this in the calculator, and I'll just type it in. So we do 85 times 2 raised to the x. And then we want to know when that equals 1,000. Now, if I just do my window like this, we can't see because 1,000, this only goes to 10. So I'm going to change this up to, we'll make it 1,100. There we go. So second trace intersects. I'm going to move close. Whoa, I'm going too far. All right, and then enter, enter, enter. That's not right. What did I do wrong? Oh yeah, it is. Sorry. It is between the 3rd and 4th week, right? Sorry. That's right. Yeah. 3.556 is between the 3rd and 4th week. I was still thinking about another question. All right. What questions do you guys have about this lesson? Do you like having multiple ways, or you just want to do it one way? Or do you care?